So we'll get started. So welcome, this is the off-the-shelf breadboard edition. And we'll just, wipe over. Oh, look at that. And we'll take that off and that off. The joys of quarantine and having to do everything yourself. Yay. And then I do have a little camera there that we might look at if we need to look at anything up close. So hi, I'm Chris, aka TechGirlMN on Twitter. And so what we're going to do in this session is we're going to build one of these on there. And so is everybody ready to get started? Oh, we need video. It's not. Okay, everybody see my hand, my sparkly nails, and the breadboard? Thank you. Okay, everybody good? Yeah, I don't have enough USB ports to do a face cam as well, so I figured this stuff here a little more important than seeing my shining face and purple hair, so bear with me. All right. Okay, so everybody got their breadboard ready and their stuff? Huh. Interesting. Yep. Well, let me ping Nicole here. Link, question mark. All right. Oh, good. See, JJ's got us covered. I just pinged Nicole. Oh, well. So we'll move on to the presentation here. So this is a solderless breadboard. Basically, it's a hunk of plastic or acrylic that's got these nice little clips in there. So that's something you put in this pin, or this hole is connected to this hole, and then there's a separate clip for those. And then actually these are one big long. Ooh, that's not flat. Okay. So that's the way this works, is that there's full of these little clips that'll let you make the connections. So what we're going to do is we're actually going to do this in a little bit different order than if you were at the first session, the Tinkercad session, or actually I think it is the same. So we're going to start with the Arduino Nano. And this is basically everything that was part of that Arduino Uno that we used in the virtual session, just in a nice little breadboard friendly package. So what we want to do is we want to start at one end of the board, and you're going to put one set of pins in one side and one set in the other. And then you're going to push really, really hard because this is a new breadboard. And like that. And so now all of these pins on either side we can actually use by plugging in our jumpers to the corresponding holes on the breadboard. All right, and we'll just give that a minute, make sure that everybody is ready. No, it does not matter if it's exactly center because it's never going to be exactly center. You're always going to end up with basically 3 usable holes on one side and 2 on the other. So no, they're never center, so you're fine. All right. All right, and just like the other project, next we're going to move on to our resistors, and we're going to make sure that they go into the negative rail. For those of you who were at the earlier session this morning, we had a little fun because I wasn't awake yet. Let me pop over to the other camera here. Pop over to the other camera. And so this is a 220 ohm resistor. This is a 5-band, so it's supposed to be resistor, and it's, God, the light's bad in here. I think it's red, red, brown, brown, black, or my vision's going bad and it's something else. Either way, 220 ohms, they should have been marked in your thing. I don't have a beige 4-band handy, otherwise I'd show you what that looks like as well. So back over here, and we're going to put in 7 of these, and you want to kind of space them out. Particular numbers are not super duper important. Just make sure that you have enough room in between the resistors for the big LEDs, because they do take up some space. So we're just going to continue on with our 220s. And let me make up some more here. And this is a handy tool. I have no idea where you would find one these days. I bought this back when I was taking my birthday money to Radio Shack, so good luck. But they do give you a nice bend. And so we've got 2, 3, 4, 5, 6, and 1 more for 7. Okay, yeah, this is a component bending tool, since you're asking. And like I said, I wouldn't know where to get one. I've had this for a very long time. I think I got it at Radio Shack. And like Tully said, there's a stencil, there's a 3D printed stencil on Thingiverse. So yeah, I've had this for a very long time. As you can see, it's Radio Shack red. All right, so you should now have your Arduino and 7 little resistors. So I am going So I'm going to go ahead, and once again, we're going to do the ready check thing to make sure that everybody is ready to move on to the next. And now these are the LEDs. These are actually big ones. They're kind of oversized. Um, they're 10 millimeters. It's actually more common. 3 and 5 millimeter are more common um, than the 10, but the 10 are nice and give a nice big effect for those boards. So we've got the long leg, which is going to be the positive anode, and the short leg, which is the negative cathode. And it seems like no matter how many times I look that up and write that down, I never remember it. So that's what I was doing in between sessions, to be honest. So let's get these set up. So what we're going to want to do here is we take the short leg and we pop it in there. And this one's going to need to sit sideways so that the short leg, the negative, the leg, the cathode is going through the resistor and into the negative rail. And maybe, yeah, there we go. And then we've got one last hole back here to hook to run to the Arduino. So let's flip over to the other camera here and see if we can't get in real close to kind of do the next one. Okay. So as you can see, I've got the one blue LED here already done. And then here is the second blue LED. Sorry, this is a microscope camera, so it's really sensitive. And there's that. And as you can see, we've got the resistor into the negative legs. And then this one, it looks like about pin 41. So we're going to want to flip this over, drop the short leg into the long leg into 40, and then the short leg into 41. And one other note here, and you'll probably see that me do this in between this session and then the coding session, is that if you need or want to, you can trim these legs down so that your components sit a little closer to the board. That does kind of help make them not so wobbly. So I'm not going to take the time to do that now, but just be aware that that is entirely an option. So let's go back to where we can see the whole breadboard. Yeah, what the heck. Yes, I'm having fun with the really spiffy trial of vMix software. Can't afford it once I have to pay for it, but it's really nice to use now. So let's move on to our green LEDs. And once again, short leg matching up to the resistor, long leg and the one next to it. And there's yet another green LED. Yes, it's oriented correctly. Woohoo. And we'll keep going. And then we've got our yellows. Same deal. Yeah, definitely going to cut these later on. And then finally our red. And there's our setup. And they're fairly even. You'll get this where they kind of like to boop a little in the clips, and that's why, like I said, before we get serious about the code, I'll probably clean this up a little bit. All right, yes, the short leg goes into the same hole as resistor. Let's clean these up here because if I'm doing that, I'm not seeing the chat, so I do apologize. Let's see, okay, and looks like JJ got that. All right. And yep. So yes, these 5 pins have nothing to do with these 5 pins, and that will become important in a minute. All right. And there we go. All right. And I think we'll go ahead and give another ready check, and then we'll get these hooked up to the Arduino. All right, so these are our jumpers. I've split them off into one set of colors so that it's easier to color code, pull out the ones I need to color code. Now, a thing with the jumpers is that going forward, go to AliExpress or Wish and pay like $1 and wait a month for a new bundle. These things, depending on what you're using them for, you want to almost consider them disposable. Because they're nice, they work real well, but they're not always perfect. So the first thing we're going to do is we're going to take off these black and these white ones, the black and the white one, and we're going to, now let's use this into the board. And what we want to do is we want to make sure that when we're sharing, that when the board gets powered up, that both rails are powered. So we're going to take the white and go from the positive rail to the positive rail, and then the black, negative to negative, and so now that we know when we're plugged in that both these rails will work fine, because we've got a ground that will eventually hook up here and a 5 volts somewhere over there. All right, so let's get the LEDs hooked up first. So I'm going to rip out a blue one. That is so oddly satisfying. Okay, so our LED has 2 legs. Now the one leg, the short leg that goes to the resistor, we want to leave that alone and put our jumper into the positive leg. And we're actually going to work backwards here from the pin, and uh-oh, I'm a little short. See, D7, D8, yep. Oh, these are a little short. Just give me 1 second here. And this is why we cut them. This is why we cut them. Aren't live demos fun? I should have recorded this. Then I could have just listened to the chat and edited out all my mistakes. Okay, so I do have a longer one here, thankfully. So there we go, positive leg, D8, big long cable, awesome. And so then we're going to take this blue and go to the one next to it. And here's a pro tip on the breadboards. When you're when you have to use holes next to each other, try to stagger the input. So like if these two are next to each other this way, you guys can see that, instead of putting them side by side, stagger them, because you'll have an easier time getting them in and out later. So if we were using 20 and 21 here, we'd go one into 21A and the next into 21B. Yep, white positive to positive, black negative to negative. Normally I might have used red there, but you got that going. Okay, so now we're going to use a green for the same concept. And D6. And grab another green off of another set. Still oddly satisfying. And go there. And there. And now we're on to our yellows. And same thing. Wire. Breadboard. And wire. And breadboard. Which should leave us with one last red at D2. Okay. Okay, yes, that's a jumbled mess. Most breadboards are. Okay, so to review, your red LED should be hooked up with a red jumper wire to where it's marked D2 on the board, yellow to D3 and D4. Greens are D5 and D6, and blues are 7 and 8. And the difference is that these are digital pins. They're either high or low, on or off. Some will have PMW, which is pulse width modulation, which we're not going to be playing with this session. And that's how you get the LEDs to fade up and down, is they have to be on a pin with pulse width modulation. So for now, we're good. We've got all of our digital pins here and here, and we'll go from there. And once again, I'm going to ask for a ready check because I don't want anybody to miss anything. I want to make sure that we all kind of stay on the same page or at the same place. All right, are we ready to continue? All right. All right, so now we're going to work on our button. And this one's a little different than the one you've probably seen or the one that we used in the virtual session. Basically, it's just got a place to snap on a little different colored cap. And it's got some bendy legs too. Okay, so just like in the virtual project, if you were in that session as well, we're going to snap this down to the end of the breadboard. There we go. Maybe. Or my legs are going to bend and magic flying tools. And hopefully we can get this bent out, because if we break the pin, we might be SOL, or I might be SOL. because I did not check my stocks on buttons before. And all right, so if you need to bend the pins a little, I'm actually going to take a moment here and flatten these guys out. Okay, trying this again. Come on, baby. Come on, you can do it. Okay. It looks like it's in. All right, so looks like we're actually in this time. Yay. Clicky, clicky, clicky. All right, so let's hook that up. And so let's start with the backside first. So here's another important tip. In fact, I'm going to do that way for you guys, just so you see it. We use orange for the button. If you only ordered the one size of jumpers and they're not quite long enough, what you can do is you can pick up a spare column here and go to that spare column. And this is why they're considered disposable, if you can see that. Let's try this again. So we're going to go from here. Then we're just going to go into any unused column. And then take another one. And go to 10. Around and in. And then stretch it over. And we'll probably go over a couple just to kind of even it out. So that's a handy tip if you're working late at night and you need to go from one end to the other and you don't have long jumpers. Just use a spare column like that. So now that we're connected to the Arduino, just like before, here's our 110 pull-up resistor. And if you just give me 1 second, see that on the big screen. Wait, there we go. So maybe I can get this in focus. There we go. And that's what a 1K resistor looks like. Different color pattern. Actually, this should be a 10K. Excuse me. While I go grab the 10K resistors because that was just laying on the workbench and now I'm not sure. Oh. I miss Vegas. I really do. And unlike our current limiting resistors on the LEDs, this is a pull-up, so it's going to go into the power. Or no, this one goes into the negative too. Never mind. I apparently need yet a third Starbucks run this morning. All right. So then we've got a green one. Thank you, John. D10. The button should be in D10. And I am still zoomed in. It would be nice if I could have had a crew, but you know, same reason we're not in Vegas. Okay. So now that we've pulled back out, we've got our double jump here to the button. We've got our pull up, and now we're going to hook this little green guy here into the power. Yay. All right. So there are a couple more connections that we need to make. If you remember, if you were at the earlier session, the Arduino and the breadboard came with a few things already plugged in. So we're going to replicate that now. And so on your board, on this side, you're going to see some, instead of seeing like say D5 or whatever, you're going to see a few other ones. Let's zoom in on that for a second. There we go. Look at that. We'll wipe back over here. Okay. So there's our rat's nest. There's the open side. So what we're going to do is we're going to start with a black one. And you can see it moving around there. And the black one needs to go from where it says GND, that stands for ground. And it can go anywhere on that, on the negative rail. And we'll wipe back. And you can see it, it's this one right here that we've put from the ground to the negative. And we'll wipe it back. And yeah, that's right. Okay. And then we need one more, and we'll use brown just to keep things kind of color coordinated here. And we're going to go from a pin that says, the pin that says 5V, that's 5 volts regulated. The other one here that's here on the corner, that's a voltage in pin. And that is if we were to say hook this up to say a 9-volt battery or 4 AA's or anything between 6 and 20 volts, you can put on that pin and power your project within reason. Don't hook it up to a car battery, not good. And then that'll go into the positive rail, and then those first 2 jumpers we placed, let me get back out here. And then those first 2 jumpers we placed will actually carry these connections over to the other side for our LEDs. All right, so that is all the hookups. And so we'll go ahead with one more ready check. Also, any questions, or if you need some help if you need to take the screen over and want somebody to check things, now would be a good time for that. Okay. Yep, up here. There we go. Yes, 5 volt goes to positive, and ground is considered negative. So this is going to be kind of weird because I need to troubleshoot the IDE on my PC because I do most of my coding on my MacBook. Don't ask. Oh. All right, now is everybody more or less ready? We'll, since we do have some time, I'll show you how to do some light testing here. Which is going to get really, really interesting. All right. So I'm going to go ahead and plug this in. And just like before, we get the little built-in LED that'll blink. Yay. All right, hopefully I can nudge enough room here. Do bear with me, guys. Apparently at some point, I mucked up my Arduino IED on my big gaming rig, the same rig that I'm streaming from. I actually do most of my coding on my MacBook. So what's going to happen is I'm going to I will show you the code because the IED does load well enough for me to show you what the code is, and then I'm going to duplicate it on my MacBook and send that to the Arduino. And yeah, so it's a little effed up, but it's be okay. All right, so we've got our Arduino, we've got it blinking, maybe, hopefully. Yep, if you haven't downloaded the Arduino software, that's fine, just watch along. And so we're gonna flip over to the desktop capture, yay, and close that, and go live, and that. And why is that not playing? Wrong one. And that's not what's supposed to be there. Oh, come on. Seriously? Let's try going out. Come on. There we go. All right. So we'll start back at the beginning. I open my thing, the Arduino IDE. The latest version actually will bring automatically up the blink sketch. This is the same code that is built in. And we're just going to modify that and send it to the Arduino. And the quickest way to do that is if you take that blank line, line 24, and we're going to hashtag define. And then we're going to pick a name. And for this case, we're going to go test LED. And then we're going to pick the first of our pins that we used, which is 2. So that basically we've defined test LED as a permanent variable set to 2. And so now we can take the LED built in and be lazy and copy and paste, or not. Really? Copy. I always prefer, if possible, copying and pasting variable names because that way you don't mess them up. So now instead of using the built-in LED, so everywhere that says LED built-in, we're just going to click in and say test LED. And then you guys are going to hit upload, but that's going to give me an error. So let me do this one more time. Over here. Copy. Paste. Paste. And then I should be able to upload. And so take care of this quick. And why aren't you working? You worked last night. Sorry. Oh, that's fun. Yep, that is the grab and go code. That's what happens when you share your screen and you've got hop-in left up, is you go all the way down the little rabbit hole. This is the screen that I meant to be showing you, and I do apologize. Like I said, no crew. You want to hit define, and then a variable test LED is fine, and then one of the numbered pins 2 through 8, and then everywhere where it said built-in LED, you want to replace that with test LED, and then we're going to click upload and upload it to the Arduino. Oh, come on. All right. All right. All right, and I'm learning the hard way in a live demo why we don't use random parts that have been left on the desk for an indeterminate amount of time. And yes, you can feel free to laugh. These are the jokes. They're the best I have. So let's go over here for a second. And yes, we are in the Matrix. So come on, you want to upload. You want to upload. Come on, come on. Okay. So what I'm going to do is I'm going to have to troubleshoot this. I think this board was bad, and instead of throwing it away, I threw it back in my parts bin. But I do want to show you what the test code does. So this is the off-the-shelf code that JJ linked, and it's actually blinking out the Diane initiative in binary using the numbers from an ASCII table. As far as the test code that I showed you, there we go. And that's not even the right code. Wow. Let's try this one. So that's some other test code that I will actually post, courtesy of Blendster, who's used it for other things, other programs that he's ran. And let's try this one. I really miss Vegas. I really do miss Vegas. And there we can see that's what your test blink sketch would look like. Should look like on your breadboards. And we'll flip this over to the blue one. And so every time you put change define to a different number, it's going to blink a different LED. Now my blue's blinking. Any questions, comments? You didn't really miss it, Jay. What happened was that this Arduino here failed and it just does not want to communicate. So I assumed it was my IDE and pulled up my MacBook just to do the code, just to upload the code after I showed it to you. So I'm going to have to redo this board tonight before we do the thing. And yes, the whole thing is that they all are recorded. As far as us using the soldered project, that was me trying to do some code demo and having a bad Arduino. Bad, evil, bad. All right. All right, looks like Vicky got the grab and go code to work. Awesome. And the grab and go code, we're going to work with that on the recorded or on the advanced programming session. I'll go through what those different things are and how to set up additional letters if you want to change the message. So those sessions are tomorrow. There's another session in Tinkercad where we're gonna go through the flashy or the Larson scanner where it goes from left to right and then right to left. And then the later session is going to be, we're going to go through the grab and go code and we'll talk a little bit about creating functions and loops and things like that in that one. And in fact, I think I get on the right keyboard here. So as a preview, this is the code we'll be writing for the Tinkercad project. And then this is the code. And this is the off-the-shelf code. And then we'll take and then both projects, what we'll do is we'll keep the button simple, and I don't have it in this particular version, but basically it'll work if the button's pressed and then not work and save on your battery when you don't want to show it off. Yes, all of the sessions are recorded. And thank you for the comment on my nails. I appreciate that. And I do kind of feel bad that some of this stuff isn't working, but you can plan and test all you want, and then of course the day of something's going to go wrong. So yes, the hardware stuff is in the sessions. Everything is being recorded. I do have nothing is perfect. This is fun. Thank you, Jen. Thank you very much. Does anybody have any questions for me? Want to take over the screen, see if they can get it, see if I can see something to something's not working right. Yes, apparently I did not sacrifice enough blood to the demo gods. Either that or I haven't drank enough. It's going to be one of those two things. I'm not sure which at this point. Right now, are you referring to this switch here, the big button? Okay, the big button is actually set up to be input, and right now with the grab and go code, I don't have it doing anything. It's just there for your own experimentation with the grab and go code. We will have it do something during tomorrow's session. Alrighty then. So since we have a half an hour, we might as well troubleshoot this. So I'm going to take this away. And close my poor abused MacBook. Yes, with all the awesome stickers. Ooh, a little bright. Oh God, I love live demos. I really do love live demos. Okay, so I'm gonna pull this apart. New in box. Hopefully, we'll keep our fingers crossed. And maybe we can actually get this to work on a breadboard. Okay, and I'm going to use these. These are ESD tweezers. These ones have a round tip as opposed to some of the other ones that I have that are nice and pointy. And you can do this pretty much with any tweezers or small screwdrivers. And to get something like this off a breadboard, it's a little stiff and sticky. So we just kind of ease it up. It's much easier to do if you have a tool versus your fingers. And we'll try this again. Ugh, come on, baby. Okay, come on, you worthless piece of bleepity bleep bleep bleep. Yay, there we go. Okay, who wants an Arduino? I'm not sure if it works or not. Raffle it off. No, we're not ruffling off the sad dead Arduino. We're gonna just put it over here in the trash can. Come on out, little buddy. Ugh. Come on out. Okay. Ooh, shiny. Oh, tape. Okay. So let's see if we can get this lined up once again. And down. And come back, MacBook. Yes. Yes, if you ever meet a member of the Lonely Hackers Club, ask them where Austin is. Do you need no more context than that? They will laugh they will laugh hysterically. So it powers, yay. And let's see if we can get. Come on, buddy. You want to do it. You want to do the thing. You want to do the thing. Do the thing. All right, tools. Doing that out, bootloader. Serial ports, right. Arduino ISP. So maybe, maybe not. I love live demos. I really do love live demos. How could we, okay, let's ask answer some questions here, since my breadboard is still not working, which is actually kind of embarrassing, but we'll work on it. So how can we check on which COM port our board is based on? Yeah, if I reboot my PC, we'd lose the stream. But I can't answer that one. So if we go back here to the IDE, up at the top, there'll be a tools section, and you can pick which board you're using. So lots of little physical computers work well with this particular IDE. It should be a Nano. It should be a 328, and should ideally be the Omega 328P. If it's not working, try the second option, which is the old bootloader. I have found that some of them, especially if you got them, especially with these clones, are still coming out from China with the old bootloader versus the new one. And then serial ports, right now, apparently the only thing I've hooked up is, I have no idea what's on COM1 right now, to be honest. I don't. Genuine boards that are like 5 times what you probably paid for this one will do two-way communication, and you'll get the board information from them. So that was that question. Yay. Let's go back. See what else I can answer for everybody. Yeah, no, I'm actually very precariously balancing my MacBook Air to try to run code to the breadboard. That looks right. That looks right. That looks right. We'll try the new bootloader just to see. Ah, there we go. Yay. So apparently the new Inbox Nano wanted the new bootloader versus the old one. Oh. So there's the grab and go. So that's the grab and go code. Let me pull up some of the other ones here. No idea. All right. Let's find the right sketch. basics, blank. There we go. Let's try this one. And there's that blink sketch with the define added. And then we change the number to 8. And then we can change it to 6. And now we get the green going. And 4 to do a yellow. Hopefully, maybe. All right. So I'm obviously going to have to do a little more troubleshooting on this. To finish getting it working. That's pretty much your homework if you want to, if you're going to be using this for the main code tutorials tomorrow, is just run that blink sketch, make sure that all 4 or all 7, excuse me, LEDs light up. There is another sample sketch that I will pull out and show you. Yep. Let's wiggle it. Yeah, I'm going to cut these legs too. Well, yeah, we'll do one where we're not, do this again when we're not going live. So if we go back and look at the IDE, under sketch or under, let's see, what is it, file? There we go, file, examples. Let's see, under digital, we'll have a button. And if we change this to 10, where the button is, and we change the LED pin to 8, because I like blue LEDs, you now should, just like on the Tinkercad version, run number 8 should come on when you press the button. And so now I'm doing this again on the Mac that's hooked up to the Arduino. And so, all right. Oh, the things we do for fun. Where am I? There we go. Wipe. Okay, so now we've got the button. Yay, the button works too. All right. So I'm going to continue to troubleshoot this, continue to ask questions. Is there a list of source? Can also double check the resistors are going to the correct location. And is there a list resource we can refer to where the resistors, LEDs, and wires go on the breadboard? I can definitely type something up for you. Quick and share that. To be honest, I kind of did this kind of free form. So our resistors on this example, one side all goes to the negative rail, and it looks like I've got them at 45, 40, 35, 30, and on down. And then, yes, and Tully's got a picture. And that's actually from this one, and they're similar. And they're incredibly similar. The first pin port ID is, let's see, it should be, did I? Let's see, D2, D2, D3, D4, D5. 2, 3, 4, 5, 6, 7, 8 on the pick. Looks like it starts on D7 instead of D8. Well, let's double check here. And yeah, it looks like this board might be a little off. Spin this around. Get it under the scope here where we can all see it. Yeah, D3, D4, D5, D6, D7, D8, and D9. Okay, so I really meant to use D2 through D8. Apparently on my prototype, I was off by 1. And if anybody followed those early pictures that I took of the original prototype version, I'm sorry. All right. It's not really, the board is fine. It's just that when I documented some of this stuff, yeah, D9 is empty. It was supposed to be, I've been doing it as D2 through D8 or something. I don't know. Somebody said one was off. Meh. Yeah, D2 through D8. Apparently on my board, it's D3 through D9, which would explain some of the coding, the weird coding errors I was seeing as when I was playing with the soldered board. But that's why we build prototypes. All right, does anybody have any other questions? Want to take over the screen if they're having trouble? It works. Yahoo! Thanks. Happy dance. I'm glad to hear it, Jessica. All right. And then as long as we're here and we have a little time, just a little note, when you go to power these things up, you can, let's go to the other screen. You can use little USB power supplies. The trick with these is what I have found is that older, cheaper, less lower capacity ones with under 1,000 milliamps work better than say that shiny new one you just bought that you can charge your phone 4 times before you have to charge the adapter again. So this one I think I picked up like at Dollar Tree or Five Below, and see it works just fine. Connected to power. You can use batteries, you can use breadboard power supplies. Rechargeable 9 volts are good too. Especially if you just want to, have it, I made the thing, I want to put the thing on my desk for a while. These are good. And that's why we're going to set up the button. That's why we'll set up our input buttons to only flash the lights when it's pressed. So, all right, so who's also going to do the soldering project that's here right now? I'm just kind of curious. Ah. Cool. All right, awesome. Excellent. All right. I have seen that. And what you want to do is you want to let it air out, unplug it, press the reset button, and then press and hold the reset button while you plug it back in. Is usually what's happened. All right, and then yeah, don't worry about your soldering skills. These are really pretty beginner friendly projects to begin with. And honestly, I've had so much practice. And I even got more this year. This was my indie badge from this year. I'll get some batteries later, but each one has 46 3mm LEDs, and I built all of these that are on my Tindy store by hand. So you want to get a lot. That's one way to get a lot of practice real fast. I did not intend to build them by hand, but pandemic. Is there a link to the Tindy store? I can get you a link to the Tindy store. Yes, I can. D-I-E. Products. Sign in. There you go. So there's the link. I know that we're giving away 3. And we've got codes for 3 free ones. If you don't win one, there are some left. And yeah. Yeah. And like Ben said, it's easy if you know technique. It can be more of a challenge if you don't. Probably the best advice I have for that is to just start watching YouTube videos, because a lot of different people approach it in different ways. And then you just find whichever technique works best for you. Like Mark uses a board hold or a third hand. I just go low to high right here on my silicone mat. I don't usually use a lot of board holders or clamps or vices or any of that stuff. Probably because, you know, the mindset of I can buy a kit, or I can make a thing, or I can buy more tools. I just learned how to do it against a workbench. There's a Goldilocks amount of everything. There's a Goldilocks amount of tinning. There's a Goldilocks amount of... Except for flux, you can never have enough flux, or you can never have too much flux. Yeah, but is that through hole or surface mount? Yeah. All right. Oh my God. All right, and now that I've found some batteries, for those of you who are curious, I think it's either this session or the next one where we're actually going to be raffling off this guy. And this is our 1978 video game character made with 1978 tech. These are well, if you really want one unassembled, I will be more than happy to send you one unassembled, Ben. We're giving away 3 of these. There are a few left on Tindy. As far as the ICs go, these are real basic because, like I said, 1978 tech. So this is a 555 timer. The way I have it configured, it's sending out a square wave. And then the longer ones are called decade counters. And so basically it has 10 pins 0 through 9, and it just steps through them based on the square wave. And then we're actually controlling how the frequency of the square wave with these little knobs. And so it goes all the way up from fast to slow